Hey everybody, I'd like to introduce you to the presentation of Team 4. It consists of myself, Alan Birch, who's going to build and design a pan flute. My partners are Doug Heiner, who's going to build and design a guitar, and Tom Phillips, who's going to build and design a glockenspiel. The reason we're here today is because a band has approached us and asked us to build a set of instruments. These instruments need to be capable of fitting in a 2x2 by 2 foot box. The instruments need to be a string, a windpipe, and a percussion instrument, and they need to play the ASU alma mater and do it in various voices. On top of that, we also have a few other requirements. The instruments combined cannot consist of more than 10 feet of tubing, nor can they consist of more than 6 feet of piano wire or guitar string. The instruments cannot cost more than $15 each to produce, and they have to be able to play several notes on each instrument. So I'll be going first with the pan flute, then Doug with his guitar, and followed by Tom with the glockenspiel. I hope you enjoy it. Hi everyone, I'm going to talk about the pan flute I'm designing. So we're going to start the presentation on my PowerPoint slide 4. And there you'll see the notes that the pan flute is capable of producing. Mine will be recreating the ASU alma mater in a high voice, so that's going to be anywhere from notes D in octave 4 to D in octave 5. And in order to do that, it's going to have frequencies of 293 all the way up to 587. And the length of pipe associated with those is going to be 5.8 inches all the way up to 11.3 inches. And so the way I came up with the lengths of pipes to use on the pan flute is I use the equations you see on slide 6 there. Once you decided what frequency you needed to produce in order to produce the required note, use that second calculation there. So the length equals the speed of light divided by 4 times the associated frequency, and that'll give you the length you need for the note you're looking for. The other equation I'd like you to look at is you have to take that actual length and subtract the 61% of the radius of the pipe in order to come up with an actual length, and that's due to the antinode moving out of the pipe. On slide 8 there, you'll see the calculations associated with each note I needed. Estimated budget for my flute is going to be roughly $12.50. That's going to include the pipe, PVC caps, PVC cement, metal tie strap, and twine. That'll just about do it, so I hope you enjoy it. Doug's up next with his guitar. Thanks.
Hi, I'm Douglas Heiner. I'll be constructing the string instrument for our Band in a Box project, which we've decided to be the guitar. I'll be covering the mid to high voice. The guitar will be a 4-string guitar covering the E, A, D, and G strings, which is the top 4 strings on an acoustic guitar. The length will be 18 inches or approximately 0.4572 meters. The note range I'll be covering will be a B flat in the 3rd octave to a G in the 4th octave. The frequencies that are required is a 233 Hertz to 392 Hertz. The equations that I used were frequency equals the square root of tension divided by the linear mass density all over 2 times the length. The stress, which equals tension divided by the course or cross-section area, and the linear mass density, which is the weight divided by the length. The budget for the guitar comes in just under budget at $14.54. That includes mainly the hardware needed, including the strings, the bolts, the wood for the neck and the fret. Everything else is already in hand, and I'll be able to use those. Thank you for your time, and I'm going to pass it on over to Thomas to give you some information on our glockenspiel.
Good afternoon. As my partners have pointed out, I'll be describing my glockenspiel that we'll be using for our percussion instrument. We'll be using it to cover the low voice range. I'll be making it out of a wood base, approximately 10 by 10 inches, tapering down to 6, which will hold 9 1/8-inch PVC pipes cut to produce the different pitches, ranging from a length of 10 inches down to 6.5. and I will be striking these with a wooden dowel for my striker. The formula I used was 3.0112 squared times pi times thickness times the speed of sound in the material divided by 8 times its length squared. The thickness was 0.00172 meters. The speed of sound in PVC was 1060 meters per second. And the length of the pipe was determined using those calculations. My glockenspiel will come in well under the $15 maximum budget, as you can see by the next slide. The justification we used for each of our instruments was our decision matrix. In conclusion, we all used the decision matrix when we decided on which instruments we would build. The main constraints were our budget and our material limitations, being that you could only have so much pipe and so much string for your instruments. We used our calculations to prove that our instruments would work for the notes we needed in order to produce our song. I hope this has covered everything, and you all have a fine day.